Hello everybody, welcome into another lesson. So today we are going to do some coordinate geometry problems. We're going to do 6 exercises here where we're going to find the missing coordinates. So the goal of these 6 exercises are that we want to supply the missing coordinates without introducing any new letters. For the very first one here, we are given a rectangle in the coordinate plane, okay? Now, in general, you at least want one of your vertices to be at the origin, right at 0, 0, right? Because the origin's at the point 0, 0. That's going to make your life a lot easier. Now, there will be a couple exercises where it doesn't start at the origin, but it'll start close to the origin. And, well, we'll get to those in a minute, okay? But we have a rectangle. Of course, the coordinate of this vertice of the rectangle is 0, 0. In the bottom left corner, 0, 0. In the top right, the coordinate is AB. That means that this coordinate here, AB, is over A units and then up B units from the origin, right? So why don't we start with this coordinate here in the top left? Well, okay, so let's start with the top left. So, of course, a rectangle, it's a flat side at the top, right? Well, it's definitely going to be up, it's going to be rather up B units because this coordinate of the top right vertice means it's up B units from the origin. So the missing coordinate here for the y coordinate would be B, because it is up B units still. But what about the missing x coordinate? Well, we haven't changed from the origin in terms of x, so the missing x coordinate would be 0. So the coordinate for this would be 0b, because it's over 0 units, but it's up B units. Okay. Now, what about the missing coordinate here at the bottom right? Well, clearly we can still see that it's shifted A units to the right, so it's over A units from the origin. So we can put that as our x coordinate for this. But what about the y coordinate? Well, it hasn't gone up any. It's still sitting on the x-axis, so the missing coordinate here would be A0. So the missing coordinate for the top left is 0b. The missing coordinate for the bottom right would be A0, because, yeah, you've gone over A units, but you've gone up 0 units. And the missing coordinate here would be 0b, because you've gone over 0 units, but you've gone up B units. So that's what they mean by supplying the missing coordinates without introducing any new letters. So that one was relatively easy. Now, we got 5 more here, which this lesson is going to prepare us to do geometry, coordinate geometry proofs, which will be the next lesson, which do kind of piggyback off of this a little bit in the next lesson. But what did they give us for the very next one? Let's draw in red for the shape so you can see it better. Alright, so this time we have a parallelogram. Now, the bottom left corner of the parallelogram starts at 0, 0 at the origin. Now, the top left coordinate has a coordinate of CD. They give us CD. The bottom right coordinate is going to be at E0. What we're being asked to find here is the coordinate of the top right vertice. So you have a parallelogram here with, of course, the bottom left vertices at the origin at 0, 0. the top left coordinate, the top left vertice is at CD, the bottom right is at E0. We don't know the coordinate of the top right. Well, where would we go? Well, again, parallelograms have flat sides, right? No curved sides. If we look at the CD coordinate, that means the D, that's your Y coordinate, that means it's up D units from the origin. Well, so would this top right vertice, it would be up D units also. So we can definitely ascertain that the Y coordinate of this vertice would be D. Now, you're gonna see why I'm doing this here in a second. What about the X coordinate? Well, we know that opposite sides of a parallelogram are congruent. So, for this coordinate, you're over C units from the origin, and for this coordinate, you're over E units from the origin, right? So if we try to get to this coordinate, it's going to be C plus E, because you're shifted over another C units from E. So the coordinate for the X would be E plus C, because you're shifted over yet another C units from the E coordinate. So the answer you should get would be E plus C for your X coordinate, and then D. Okay, got 4 more. Now, what is the next one? Good one, we have a square. I'm going to draw a little in red here along the axis. May not be the best square I ever drew, but that's a square. Well, I guess I better extend this out then, right? If I'm going to, that's fine for that side, but I probably better extend the left side a little bit to make it look more realistically like a square. Alright. We'll call that a square. Alright, so we have the coordinate of the bottom left vertex is going to be at negative f0. The coordinate of the bottom right vertex is at positive f0. What we need to find are the coordinates of the top left vertex of the square as well as the top right vertex of the square. So this is going to be a good one. So keep in mind this is a square. So if let's look at the coordinates we already have here. So let's try to find the distance actually, which would be the length of each side. So look at your x coordinates here. You go from negative f to f. If you go from negative f to f, what would be the distance? That would be 2f, wouldn't it? So each side would have a length of 2f. Each side has a length of 2f for the square. So if each side has a length of 2f, what does that mean? It means that then your left and right sides will also have a length of 2f, which means then that the y coordinates for each of these will be 2f. So each of these would have a y-coordinate of 2f because it's gone upwards 2f units. Alright, so now what about in terms of finding the x-coordinate? Well, the x-coordinate would stay the same as for the top left as the bottom left, because if you look at the top left, you haven't gone anywhere in terms of x, you haven't shifted left any further, so you'll end up having negative f for your x-coordinate. So the top left coordinate would be negative f 2f, and then if you look at your top right, well, yeah, you're up 2f units, but as far as shifting left or right, you haven't moved at all from the f, so the x-coordinate of the top right would be positive f. So you would get the coordinates negative f 2f and then f 2f. Those would be your coordinates for the missing coordinates for the square. Shit, man. There we go. Alright. Hold on. Hold on. I had to kind of butcher this a little bit. Just a little bit. I want to give you all a clear picture. Okay. There we go. Reconnect that. Let's see what the next shape is that we get. Alright, so we are given an isosceles triangle here at this time. So the bottom left vertex is going to be at G0. Alright, the bottom right vertex is going to be at H0. We need to find... We're even given that the y-coordinate of the top vertex is J. What we don't know is the x-coordinate, so we simply need to find the missing x-coordinate for the top vertex of the triangle. Okay. So, what do we know about an isosceles triangle? Well, what do we remember about altitudes in isosceles triangles? If you draw the altitude of an isosceles triangle, it's going to occur exactly halfway to the bottom side of the triangle, and it's going to create two equal right triangles, is it not? Which means that the altitude is actually the perpendicular bisector of the triangle also at the base. So, what is true if it's the perpendicular bisector? That means it occurs halfway between G and H. So what would the coordinate be where the perpendicular bisector meets the bottom base? Well, if you want to find halfway between G and H, don't you just add G plus H and divide them by 2? That's exactly what you do. So the coordinate of the perpendicular bisector where it meets the base is at G plus H over 2, and then 0 because you haven't gone up anymore. So we found the coordinate of where the perpendicular bisector meets the base of the triangle. Now, if you draw a line, this line's going straight up, that means the x-coordinate also would be G plus H over 2, right? So really what you would have for your coordinate here would be G plus H divided by 2, because if you if you go straight up from where the perpendicular bisector is to the top vertice, you haven't moved anywhere in terms of x, but in terms of y, you've moved j units. So the coordinate of the top vertice would end up being g plus h over 2, then j for your y coordinate. Alright, so I got 2 more problems. Yes, I know this is a little bit different than what we've done so far in this course, but it is very necessary to explore coordinate geometry. It does help. Alright, what's the next exercise? Another parallelogram, but this time it's going the other way. Alright, so there is another parallelogram here. Of course, we got the bottom vertice at 0, 0. That's the bottom left vertice. The top left vertice is going to be at MN. So we know the top left vertice to be at MN. The bottom right vertice is at H0. What we need to find is the top right vertice. So, okay. So we're being tasked to find the top right vertice of this parallelogram. Well, let's take a look here. You start at the origin for the bottom left. At the top left, you have the coordinate MN. At the bottom right, you have the coordinate H0. So what's this coordinate? Well, okay, let's start with the y coordinate here of this missing coordinate. What can we say about the y coordinate? Clearly, it's going to be up n units, right? Since the side is level, that means the y coordinate of the missing coordinate is definitely n. It's up n units still. But what is the x coordinate? We remember, again, opposite sides of a parallelogram are congruent. Well, this here, of course, this coordinate is over h units from the origin. That's the x coordinate. And then from here, it's over m units. So if the opposite sides are congruent, that means the coordinate here for the x would be h minus m units. So the x coordinate would actually end up being h minus the m. So you get a missing coordinate of h minus m, then n. That would be the missing coordinate for this parallelogram, h minus m, then n. I got one more problem, then we're done for the day. See, there isn't much to this, though. It's not as bad as it looks, but alright, what do we got for the next one? Of course, let me reconnect my coordinate plane a little bit here. Okay. Now, we are given an isosceles trapezoid in this case. Alright, so we have an isosceles trapezoid in the coordinate plane. So let's see what coordinates we have. We know the bottom left's the origin. That much is clear. The bottom right has the coordinate n0. So the bottom right has the coordinate n0. And then you have the top left has the coordinate PQ. So we got the top left coordinate of PQ. What we don't know is the top right coordinate. We need to find the top right coordinate. Okay? So Now, why don't we start with the y coordinate? That always seems for some reason to be the easiest, to start with your missing y coordinate. Well, we have the top base of the trapezoid. Clearly we could see from the top left it's up q units from the origin, just as this vertice will also be. So the missing vertice for the y coordinate is definitely going to be q. So that much we can ascertain about the missing part of the coordinate, is the missing y coordinate is q. Now, what about the x coordinate? Well, we know at this point you're over n units from the origin. Now, isosceles trapezoids, the legs are congruent, right? In an isosceles trapezoid. So, if this is over p units from the origin, what that means is then you're going to take this n coordinate here for the x part, take that coordinate of n for your x value, it's actually going to subtract p. You'll actually end up getting n minus p for your x coordinate. So the missing coordinate would be n minus p and then q. That's exactly what you would get. So that's really it for coordinate geometry problems. Next lesson we will do some coordinate geometry proofs. So I hope everyone has a great night. Take care.